Hi everyone, in today's video we will study how we can fade an LED using analog write. That means using analog output how we can play around with an LED. So it is somewhat similar to the last video, but in this video we will focus more on this, and also I want you to do some more analog practicals so that you can understand what actually happens. Even if you don't understand when I explain the things, when you are doing the practicals, more and more practice with one time explanation that I did, then you will somehow start to catch the things, right? So what we are going to do is we are going to eliminate an LED using analog values. So the question is, what is the difference between eliminating an LED with the digital value and an analog value? So fundamentally, if you write a digital write to a particular pin, and if you connect that LED to a pin, so let's say 13, I'm just writing the line, hi. If you do like this, then that means the pin number 13 will get 5 voltage. So there is a full elimination of an LED, right? That means the LED is in its maximum brightness. So what else you can do with digital write? You can also write a low. That means what? You are switching off the LED. So then what does mean is that particular pin will give 0 voltage. That means the LED will be completely off. So using digital write, we can only experience this kind of scenarios. So what if you can change the particular voltage to a less one, let's say 4.5 voltage or 3 voltage? This 5 voltage, if there's a way to change to various voltages, right? 2.8 voltage, 1.25 voltage maybe, and even 0, and any in between values within this range between 0 to 5. So maybe 4.9, and also we can include 5 as well. So if we can give these kind of voltage values, what will happen to the particular LED? What will happen is the LED's brightness will change. In 5 voltage it is at the maximum, in 4.5 it is a bit lower than the maximum. So in 3 voltage it may be around bit more than the half of the maximum. So in 1.25 it is a little bit elimination. It is almost off, but it is not off. So that kind of things will happen if you do it to LED, right? So you can directly do it and see, right? So that kind of thing will happen. But using that means you change the voltage or current or something, and by changing them, actually what you do is basically you change the voltage anyway. What you do is you obtain different level of illumination of the LED. That power of the LED can change, right? So in digital it is either maximum or 0, the lowest. But in analogs, in another way, let's not talk about it. But if there's a way to do this without that, not only that way, because in digital you can only have this 5 and 0, but there are some other ways. Let's say there's another way where you can obtain the in between values also, including the maximum and lowest values also. The all the values you can obtain. There's a way, but with digital you cannot do it, because only ones and zeros are possible in digital. Only 5 and 0 is possible in digital when it comes to voltage. So, but what is the way? If you use analog output, then you can get all these values. Maybe 3.2, any value, you can go for any values. So basically what you can change is you can change the power of the LED, or you can change the illumination of the LED, you can change the lightness of the LED, right? You can slowly increase it and slowly decrease it. You can do that actually, right? Using analog outputs, but with digital you cannot do it. So what I will do is I am going to give, so to that what we are using is analog write. So you should know that, right? And particular of the pin number, whatever the pin number, let's say if it is A0, it has to be A0 and the value, and the value will be somewhere between 215 to 55 to 0, or 0 to 255 when it comes to analog output. When it comes to analog input, that's a new story. That is a whole different story. You can go and watch the previous videos. I don't want to talk about that now. That may confuse you. So if I going to get 5 voltage, I need to give 255 as the output. If I want to get 0 voltage, let me quickly press the spaces. Oh my god, what's the BBB? 0 voltage, I need to give 0 as the output value. I mean, I'm talking about the value I'm passing here, right? So 255 is here, so that means if I want to get 5 voltage, I can give 255. So if I want to get intermediate value, let's say I can give 127. That's totally fine. So that can be somewhere around half of the value. So that can give somewhere around 2.5 voltage. Or actually exact 2.5 voltage. Just don't worry, it is about half, right? So this can give almost half of the voltage. That means 2.5. So the power of the LED or the illumination of the LED will be half of the maximum. So you can obtain that kind of values. Maybe you can have 200. Why not 190? So I need to decrease the spaces. You can have any values. So that value you have to pass here. Okay, where? Here. Okay, that's understandable. That's very clear, right? So actually this whole 5 voltage you are going to divide between 0 to 255. Okay, even then you can find out what is the voltage value of this one unit. That goes up to 255. So if you divide 5 by 255, you can even see what is the voltage value of 1 unit. And if you give 1, then you will understand what is the exact voltage value given to the particular pin. And another thing is you have to use analog pins. You can use digital pin as well. Just don't think about that now. For the moment, just remember to give analog output, you have to use analog pin. So let's get into the work. So I will delete these things and I will rewrite them, right, as a coding. So I wrote this for your explanation, for your better understanding. So let's go faster. So what we will do is we will eliminate an LED value to a higher level and we will decrease that. Okay, first I will write void setup and void loop. What is happening? Okay, void setup. Okay, cool. And what else we have? We have void loop also. All good. So we have gone through this so many times. So inside the void setup you have to write pin mode, whether the particular pin is output or input. So I am going to use pin A0. Since this is an analog pin, I am going to use it for the analog output. A0 as an output. And now why I should write it inside void setup. So if you don't understand that, just go have a look on the previous videos and come back. And then you will understand, because we talked about it so many times. Okay. So A0 output is fine. So inside the void loop, I am going to pass the different values of analog write. So basically what I will do is I will first switch off the LED, keep it off, and I will slowly increase the LED values with a small delay. So first I will say analog write A0, let's say 0. That means the LED is off. Okay, because now I explained the scenario, right? A0. Then I will give a small delay, let's say 30 milliseconds. Very small. Okay, so you can decide the millisecond later from depending on your output. Okay, 30 millisecond, and I will increase it to a little bit. So what I will do is I am slowly increase the power of the LED and slowly going to make it off. That means I am basically fading the LED. First increasing and dimming, increasing, dimming. So it makes a nice picture, right? Rather than on and off, rather than the digital stuff, it makes a nice picture. So what I will do is I will copy these things, because this is going to be repeating, right? Anyway, no matter what. So I will copy these both and I will try to have them. So I know this kind of scenario would happen. So I wonder how I can handle this. But if I do like this may work, no? Okay, then I will increase it, let's say 50 by 50. Okay. But you have to go for a very small increment. If 50 is too big, you can go 10 by 10. But since this will take too much lines to explain, and write, since if you understand the concept, that's fine, right? So I'm going for 50 because you can understand it very fastly. Then maybe 100. I'm increasing the power by the value 50, right? So you can measure what is the voltage value for the 50, okay, and you can find what is the voltage value you are increasing, what we call in between each and every delay. So you can have a look on that. Where's the damn thing? Okay, so maybe 150. I'm increasing by 50, and at the last shot I will increase by 55 because that's the maximum value. So I will go fast. I can delay you guys. So, and one more 255. So if you do this and then have a look what happens, you may find this coding will increase the value of this power of the LED slowly. Slow switch. The LED will be slowly. First it will be off and it will slowly increase its power, right? And it will come to its maximum power at this line. Which line? On that line number 16, this line. Then what you can do is you can go back, you can reverse this process, you are going to again make it off, okay. So because the thing is here it is 0 and it will slowly increase and come to the last line, and after the last line it will again come to the first line, right, because it is void loop. So the off will be sudden one, so increasing will be okay, but there is no decreasing. After the maximum it is immediately 0. So sudden off, then slowly increasing, sudden off. Then you can tune that as well. What you can do, you can slowly decrease the value. So what I can do is I can tell you like this is 255 now. Then again you go down, go to the 200. Okay, same amount of decreasing. Okay, and again you may like go to the 150. Okay, I am missing out the semicolon. Okay. Oh my god, this phone sucks. 150. Come on, guys. Okay, 100. 100. Okay. Okay. And we have 50. Okay, 050. So we are slowly decreasing it. So why I may bring it to 0, but I don't want to bring it by, because the first line itself is 0, right? So after this 50, immediately it will go to the first line. Then it will be off here, 0, right? So that's fine. So I start and slowly increase the value, power of the LED, and after that line number 16, I will slowly decrease the power of the LED up to 50. And when it comes to the first line, again it will come to 0. So I hope this is understandable and you get the point. So I'll scroll down so that you can have a look again. So don't come and tell me, okay, we can do it with the for loop very easily. Yes, I know that. But the thing is, we didn't study for loop yet in the tutorial series. So I just want to have a look on how we can do some different things using analogWrite output. I just want you to know that, okay? If you give a particular analog values, you can change that means you are giving a different or particular voltage values. So that immediately, or that in other words, can change the output of this whatever the actuator you are using, or in other words we can say can change the LED's power, LED's illumination can change, LED's brightness can change. So basically we are increasing the LED's brightness and decrease it in a perfect or acceptable equal intervals, okay. So that is it, and the delay should be more or less than this, I know. So that's a good idea. You can write more lines with that if you have time. Yes, for the sake of the video I took delay as 30. I'm sorry, not the delay, yeah, delay. And also these values will be not 50 actually, difference. It has to be less than that, maybe 10 or 20 like that, okay. So using a for loop we can do it in a more beautiful way. So after we studied for loop we will come to that. For the moment, just if you understand the analogWrite can give a different impact on the LED's brightness. It can increase the brightness and decrease the brightness, and how it can be done. If you know this much, that is enough for the tutorial, okay. So try coding with the very less values like 10 value increasing, right, A0, 200, 210 like that, and decreasing again with the 10 values with the delay of 30 or 20 or something, and changing those values, change those values, those increasing values, that means increasing different, and change those delays and see how that outputs may differing, okay, using a simple LED, right. So that's all for this tutorial. We will look at the continuity of the topic or a new topic in upcoming videos. Please consider subscribing us, and until then, have a great day ahead. Bye.